cascading into Kilauea's Nepal crater. This is still ongoing on day 5 of Kilauea's ongoing flank eruption in its Middle East rift zone, even creating a rainbow at one point, although the rate of lava effusion does appear to have decreased in the last 24 hours. So much molten rock has poured over the edge of its crater rim in fact that its slope has transitioned from what was likely around 85 degrees to around 75 degrees, as you can see in this USGS photograph. Yet, while a 50-meter-high lavafall is still pretty cool to witness if you want my totally unbiased opinion, it still does not compare to past lava falls which formed in the East Rift Zone. For example, on August 5, 1969, an early pulse of the Mauna Ulu eruption resulted in lava cascading down the now completely filled Inalei pit crater, resulting in 165-meter or 541-foot high lava falls, involving an eruptive rate 13 times higher than the current eruption. Back to the ongoing eruption, lava has continued lava field expansion to rapidly cover slightly more than 2/3 of the Nepal pit crater, almost entirely covering its southern third during the last 24 hours. Molten rock is still flowing in this direction as it marks the lowest topographic point on the crater floor, specifically being fed by a variable rate of lava effusion of between 5 and 15 cubic meters per second. This is a fairly low figure, almost identical to the long-term average eruptive rate of Iceland's Fagradalsfjall volcano during 2021. Regardless, when combining all lava flows which have erupted this week, Kilauea's latest flank eruption has now covered a total of 0.559 square kilometers or 138.24 acres. All of this has been emplaced in a remote region far away from structures, with 86% of the total lava erupted so far ending up on the floor of Nepal crater. This begs the question, why does Nepal crater exist pit craters in the first place? While it might initially look like a small caldera or a Mar explosion crater, it is in fact neither of these, instead being best classified as a pit crater. Pit craters are not formed by volcanic explosions but rather much like sinkholes, by the ground collapsing underneath them due to cavities forming. In this case, the cavity was likely related to the draining of an ancient pocket of magma of which there are many in Kilauea's East Rift Zone. This pocket of air then migrated upwards over time, until reaching the surface sometime between the year 1250 and 1600. We can thus assume that the body of magma that once underlay Nepal crater by more than a mile was approximately the same width as the modern crater, and that it was once much deeper.